hold it in from now on.
Okay. All right, it's all yours, sir.
All right. So let me find the share button. So good day, everybody. Hope everybody's doing well in whatever room they may be in their house, whether it's living room, kitchen, dining room. In my case, in my bedroom right now.
Dining room.
Dining room, nice. Well, hope you get a good meal while enjoying learning about Databricks. So as Tim already introduced, my name is Ayman El-Ghazali. I'm a senior cloud solution architect at Microsoft, focusing on the data platform, and I get in trouble a little bit dabbling in big data and some analytics. And this is where I found myself in Databricks recently, and I thought, hey, great time to talk about something that's probably going to affect a lot of our careers as data engineers, DBAs, data analysts, or anyone who just loves data. So this is going to be a very, very high level introduction to Databricks. So if you're expected like a 300-400 level session, then you're probably in the wrong place. Well, not probably, you are in the wrong place. Today, we're just going to go over the basics of Databricks architecture, what workspaces are, how to use notebooks, coding in notebooks using Python, Scala, and SQL, and running Databricks notebook via Azure Data Factory. Sort of want to show you how to completely orchestrate it within other services in Azure. And as for my slide deck, that's pretty much it. This session is very much hands-on, and I'll be working through the notebooks primarily. I'm going to turn off my camera for bandwidth purposes. And just in case my code doesn't work, you won't see any negative reactions from me. All right, so first of all, I hope that everybody can see this. Feel free to type in any questions you may have. I can actually see the chat, and I will take them as I find a natural pause in our discussion. So first of all, what is Databricks? Databricks is basically a PaaS offering. It exists in Azure, it exists in AWS. I don't think that it exists in many other cloud providers, but they could potentially. It is a managed Spark service, basically. And a lot of us come from, well, I don't know, a lot of us, we probably should take in a poll to see what people's backgrounds are. But as myself, coming from a traditional database background, I'm trying to present Databricks and Spark to sort of show the contrast, but not necessarily say which one is better, because in the modern data warehousing or a modern data estate, we use many tools. I wouldn't say one is better than the other. Rather, one is used for one purpose and the other is used for another. I always use the analogy of Spark maybe is a Ferrari. So beautiful car, everyone wants to have one, super fast, but probably not good for someone who has 4 kids like myself, right? Well, I mean, I'd still want a Ferrari, but beyond the point. So something like a SUV or a minivan or a family sedan, right? Not saying one is better than the other, just rather one has a specific use and the other one has a specific use. So Spark itself is just basically a cluster of machines, right? Very simple, high level. They are mostly just compute resources, although they have some storage on there. But Spark doesn't rely on storage like a HDFS would, right? So if we look at HDFS, it's basically a bunch of nodes, right? Oh my God, my handwriting is terrible and my drawing is even worse, but bear with me here. It's a bunch of nodes, and these nodes have data, right? There's some different colors here, and that data is replicated across those nodes for A, high availability, and B, for performance, right? Because you have more nodes working, so you can perform better. And once you need to scale, all you do is just add another one and you keep scaling. This is sort of Hadoop at a very high level, all right? With the traditional sort of SQL Server world, Oracle world, DB2 world, what you would do is you would have this wonderful machine, and whenever you needed to scale, you would just scale up. You'd add more hardware, right? Add a couple more gigs of RAM, and then you're going to reach a ceiling at some point where you can no longer scale that hardware. And so this is sort of the difference between the two architectures. Where Spark comes in is it's very similar to the way that Hadoop works, but it uses memory as its driver more than disk. So it tends to be faster, right? But I'm saying faster in quotes because if your workload doesn't fit in memory, it's still going to use disk, right? But for all intents and purposes, Spark, when it does processing, is a lot faster than traditional Hadoop, right? So here's the basics. The driver sends tasks to these executors. The executor runs a task. If it has an empty slot, if it doesn't, it waits. And that's pretty much how it works. It's just going to process data as it comes through, right? And one of the advantages is that this ecosystem works a lot better with data that's not structured, whereas SQL and the relational world, or even the dimensional world, really relies on structured data, especially for writing, which can cause performance issues, right? So in this world, we don't really care for schema. We're going to dump all of our files in some sort of a storage like Hadoop, Data Lake, which is technically Hadoop under the covers, as CSVs, as Parquet files, as text files, as JSON files, and then worry about adding schema to it later as we start to process it, right? So this is a notebook right here. Before I go any further, this notebook, I have a link in my slides to it, and we'll provide the link if you want. It doesn't belong to me, actually belongs to Blue Granite, who worked with Databricks to put it together. It's sort of my slides for the day. And this is the interface that you get with Azure Databricks. You are programming in notebooks. You can use notebooks in Azure Data Studio as well, if you ever used it. I don't know if they'll come to Management Studio, but that would be kind of cool. And the main data interfaces that we'll work with today are the data frames, excuse me. Basically, the way to look at it as RDDs are a form of data that's coming in as data. It's not structured very well. It doesn't care for structure. And then the data frame is sort of where people who come from a traditional database background tend to sit, because that's where you start to structure data in columns and rows and make it look like your tables. Okay, there's a couple more things just off the bat so you understand what you get with Databricks. I already mentioned notebooks. They have a lot of different languages: Scala, Python, R, SQL. I believe they are adding Java as well. You have Workspaces, which is basically a way to organize your work. Here's my workspace, and these are a bunch of notebooks. I can see what users, have access to my workspace. As you can see, I have two of my colleagues. One of them happens to be my brother, actually works for Microsoft, and another colleague on my team. They have access to my workspace. So it becomes a place where people can develop in tandem. Let's see, what else do we have here? Dashboards I won't go over, libraries I won't go over. And the last two things I'll go over before I actually get into some code are the clusters and the jobs. So jobs, I think, is quite basic. You create a job, you want to run a notebook at a specific time, and you set it to run. Pretty much just give it a name, set the schedule, and you're done. That's one way to sort of orchestrate running Databricks notebooks. Clusters are clusters. They are machines. They are compute nodes. And because Spark uses compute, you want to sort of focus on the hardware that you will get to process your data, right? And don't worry about sort of where the storage layer is. That's outside of the scope of what you have to worry about when using Databricks, right? I'm not saying that you totally ignore it, but at this point in time, your main concern with a cluster is how to set up the hardware to make it perform according to your workload. Right, so you give it a cluster name. you want to pick the runtime for Spark and Scala. 3.0 was announced. It's now in preview, so it has a couple new features in there. But you can also create clusters on much older versions if you wanted to test some legacy code, or if you're not ready to upgrade to a newer version of Spark or Scala. Some of these clusters are GPU bound, and GPU processing helps a lot with data science type workloads. The other thing is you can specify how many worker nodes you want, and these are actual physical pieces of hardware, or in this case, they're virtual machines, but they are machines that are dedicated to work in your cluster. If you enable auto scaling, you'll get that option. Otherwise, you will get just a certain number of workers, and when you turn the cluster on, that's the number of workers you get. So if I enable auto scaling, it can go between 2 and 8 workers depending on my workload, which is a great way to save, money, because Databricks is obviously not for free. Although you can get a free account to test everything I'm going to show you today. You also have the ability to terminate the cluster, which is nice. And if you think about it, data is saved outside in a data lake, so you don't have to worry about your cluster being on until you actually need to process data. All right, so let me dive into my first notebook here. Okay, there is a whole process to connect to ADLS Gen 2. I have made my notes, and I have also put the actual documentation from Databricks on how to do it. I'm not going to cover it today. It'll probably take me about 30 to 40 minutes to get it done. But just wanted to highlight that I do have a lot of documentation in this notebook, and I will provide it for you in my GitHub repo. Right, so this is my notebook. These are like commandlets. You can minimize them if you like. If they're in your way, you can make them bigger. You can run one cell at a time. You can clone cells by copying them and pasting them. You can add titles to them. You can show results, hide results. There's a lot of fancy stuff you can do in here. It's actually a really nice development environment. If there was somebody that has access to my development environment at the same time, you would see their cursor just sort of going around here like you do in like a, if you have a Google Doc or something that you share with someone, you can actually see them working with you at the same time, which is pretty nice. This is sort of source controlled on the back end. So as you make changes, it's going to automatically save, which makes it a great place to do development. You can choose to add comments in the side if you don't want to actually make any changes, but you can also comment in your code depending on what language you choose to code in. So when I created this notebook, I chose Python as my main language. So every cell that I create will understand Python code naturally. And this is the way to comment in Python, is to have a hashtag. There's something called the magic command. And this magic command allows me to change this cell to a different code flavor, if you will. I don't know if that's a proper terminology, but this cell, I changed it to Scala. And as you can see, Scala has a different way to comment code out. Again, this is just a little bit of my documentation that I've added here. You can actually add Markdown language to a cell. It's very easy. Just do %md, which is the magic command for Markdown language, and you can say anything you want, like hello NOVASQL. You just press Control Enter, and it actually quote unquote executes that cell. I say execute because there's nothing to execute in Markdown language. All right, so next step for me is to connect to my ADLS Gen 2 account. There's a lot of code here. When you take this code, you can fill in your own storage account name, your own app ID, which acts as a server principal name to connect Databricks to ADLS, so it authenticates properly, and a bunch of other stuff that you can fill in. I tried to make it as easy as possible so that you can use your own Active Directory subscription in Azure to set this up. Okay, so One other thing I'll mention here is my cluster's actually down right now. It's not working. Well, it is working. I just didn't start it because I don't need to. These notebooks actually save the results directly into them. So when you open this notebook later, when you download it from my GitHub repo, you'll be able to see these results as they are shown right here without having to run anything, which is kind of cool because you could take a notebook with the data in it, send it to someone else, be it a data scientist, be it a data analyst, and they can actually see part of the data that you're working with. Right, so that I actually don't have to run this for my demo, which is great because as we know, a lot of times when you run demos, things tend to break. This is the basic way to create a data frame, which is the equivalent of saying, it's very similar to an external table in SQL, but your data frame is basically just this higher level structure that creates something that looks like a table. But in the back end, what it's doing is it's connecting to an actual file. In my case, it's a text file right here. And it's just creating this structure over it. Similar to how you would create a view over a table, this is basically creating a structure on this unstructured data pretty much, right? So it's an abstraction of this text file. And whoops, sorry about that. It happens to have a pretty good schema. It happens to have a header. So I can set header to true. It's going to pull the header and give that header the column names in the data frame. It happens to have a pretty decent schema, so I can infer the schema. Otherwise, as I'll show in a later example, when the schema isn't good, you actually have to create it. Otherwise, this would fail. So now I've created my data frame. I use a simple command, display, and the name of the data frame, which is df1, and it displays my data. Not too difficult to understand, I hope. If anyone has any questions, please feel free to type them in the chat window. As I said, I can see it and explain further if needed. This is the same code pretty much in Python. Whenever you run code, it's going to translate it to Scala to be run on the Databricks cluster. I happen to find Python just slightly easier to code in, and I say slightly because I'm not an expert in it. But it just seems like the nuances are a little bit closer to SQL than Scala would be. But I don't think that there's any significant performance impact in choosing one language over another. Right, so same thing. I created my data frame. I gave it a name. I gave it a path that it's connected to. I can use the show command, very similar to display. It's just more sort of text-based, and personally, I find it a little uglier, but it is what it is. Now, one of the cool things is a lot of the functionality in Python that you're used to doing with SQL queries exists already. Like, for example, a where clause. You can use a filter command. Not very difficult to do. It's basically selecting the name of the data frame dot filter and giving the data frame name again and what column I want to filter on, and then specifying the value. And then I want it to sort, so I do dot sort, data frame name, and the column that I want to sort on, right? And then I do display filter data frame. And I'll take a pause here to explain why I created a new data frame. The thing about data frames is they're immutable. So once you create it, there's really no changing the data inside it. So we tend to create a new data frame to represent what we want from the current data frame. And you may think it's sort of a waste of space, but at the same time, what this is doing is it's keeping the data where it is. It's just saying, hey, I want to take that framework that you created before, and I want to create a new framework that's slightly different. And in this case, my new framework is going to create a data frame that's filtered where the city is Washington, right? Washington, D.C. Had to represent the city I live in here. So not too much different than how you would run a where clause in SQL, or rather any programming language. One thing I'll note here is that this won't work because display is capitalized. So Python is very case sensitive. This will not work because F in filtered data frame or a filtered DF is capitalized. So you have to make sure that everything that you're doing is pretty case sensitive. Hopefully that doesn't drive anyone too crazy. Right. I can also do aggregations. You'll notice at the top here, it says from PySpark SQL functions, import star. This is telling my cluster to import functions, specifically SQL functions from the PySpark library into, sorry, it keeps moving by itself, into the current cluster that I'm working on. By default, not all of the libraries are included. I would guess that the reason for that is to reduce the number of libraries, probably gets better performance, but there are tons of libraries that you can import and use in here. So what I've done is I've imported a specific function here that allows me to do group bys and aggregate specifically. So I've taken my data set, data frame 1, and I've created a new data frame called city state count. Basically said, I want to select city, state, customer ID. I want to group by city state and get a count of distinct customers per city and state. And here's the results. Pretty straightforward again. Now, in terms of understanding our data sets, we may create a data frame and later kind of forget what we have in there. But an easy thing we can do is just call out the name of the data frame, .print schema, and it'll actually print out the schema for us to let us know. City is of type string, is it nullable, so on and so forth. Very easy way to figure out the schema for your data frame, sort of like looking at the information schema in SQL Server, if you will. Okay, so the next portion of my demo here, I'm actually going to import a lot of different sample data files that I have into my cluster here. I have a lot of them. I have sales data, I have customer data, I have order data, and each one of these is going to go into a separate data frame, right? One of them doesn't have proper headers. Okay, this one specifically, it's my customer retail data. It doesn't have proper headers. So what I've had to do is I've had to create a schema and lay out the fields in the schema, customer ID, first name, last name, so on, the data types, and whether it's nullable or not. And when I load using the same code that I would load a data frame in, instead of having schema being inferred, I actually use this parameter to say, hey, .schema, the name of my schema file, if you will, and is going to apply this schema on top of this file that I have here, this text file. All right, and we can take a look at it here. What's really cool is that whenever you run these commands, you'll see that it'll start to show you what the data frames look like that you created after the command. So I can see the retail one, which did not have any schema attached to it, has now, you know, address ID, customer ID, and so on, what I created for it. So it's a nice visual representation to say, hey, this is what you were trying to do, and these are the results of what you were trying to do. Okay. Next stop is sort of getting out of the Python world. I'm not an expert in Python. I have more expertise in SQL, to be honest. So what I'm attempting to do here is convert my data frames, the, I guess, 6 or 7 or 8 that I created above, into views, right? Now, these views are still in Databricks. Databricks has this concept of databases, which is basically a metadata framework. Whoop, not here because my cluster is off. Let me start the cluster and show you what that looks like. But what it does is it creates this database that has metadata inside it that allows you to act as if you are using a traditional database with the data still being saved in blob storage, ADLS, S3, wherever you store your data, basically in a data lake. Right. So each one of these, I'm going to use the dot notation. Here's my data frame. Dot create or replace temp view. This is a function, and this is the name of the view that I want to create. Right. And now I can actually start to query this using the magic SQL command. So when I put %SQL, this cell here becomes, a cell that I can write SQL in. And I can start calling these specific views that I created above, because SQL is not going to understand what a data frame is, but it will understand what a view is or a table. You can see I've done a union, so I'm combining all of my customer data from my various data sources, right? You can see this is tons of data, pretty simple test data here. I can, well, actually, let me go back here. So these are just selects from the temporary views that I created. I can create a view that actually aggregates all of this, right? And now I don't have to write that pile of SQL code. Instead, I can just say select star from customer data, and it will know that this view is basically the construct of those data frames, which pull data directly from my data lake. Created a couple of views here for my sales data as well. Same thing, just simple joins that you're used to in SQL. In case of my sales data, some of my order data and some of my customer data exists in different tables, so I have to join them to bring all of the data for sales. I can also write CTEs against data if I want. Very simple, the same way you would do it in pretty much any SQL language. With statement, I have my aggregation here, and then I select from it. You can see a nice tight piece of code there. I can select a different way to visualize it. So this is technically the same code above, but it's not visualized in a table. You see, here's the table. I can pick bar chart if I want. I can pick line chart. Oh, I guess I'd have to change the plot items here. Let's see, that work? Nope. That's why you don't do these during an actual demo. See if pie chart comes. No, it doesn't look very well, but you get the point. You can choose different ways to visualize your data directly here in this notebook. And as I said, this notebook isn't running, right? The cluster's still starting up. It hasn't started yet. And I can choose to actually download this data as a CSV. So if I wanted to download summarized data that doesn't include potential customer information and share it with someone, I can download this as a CSV, which is pretty neat. This data I happen to plot geographically, and it's pretty nice. It's sort of like a mini report right in your data. Maybe for developers, they might not care as much, but for data analysts, data scientists, they certainly care to see what their data looks like as they're working with it. Okay, next step is I have created these data summaries using different views or using a CT or whatnot. And I actually like these summaries of data. So what I want to do is I actually want to save this data inside my data lake as is. 1 second. Is it? It's not showing up. closed in the background. I was trying to show you in Azure Data Storage Explorer what it would look like. So first of all, I'm going to create this variable as a data path. And this data path is basically saying, whenever this variable is called, I want you to use this path, as opposed to me having to write it out every single time. So when I'm doing a Spark SQL write right here, I'm saying, hey, Spark, I want to do a SQL write using this SQL statement, select star from customer data, which is a view I created above. And I want to write in Parquet format to this path, which is the path above. I could, place the whole path here, but it would make my code look pretty ugly. And then I can select different options I want. I want to use compression. I want to overwrite the data. And there's several other options. And I've included a different methodology to actually write the same code, because the thing about Python and Scala is there are different ways to write the same code. It's not necessarily one way is better than the other, just maybe one looks better aesthetically or one performs better, but there's certainly many, many different ways to write the same type of data. Let me try to put this up on screen here. Okay, here is my storage account. Here is my file path. It was an output, and you can see I have Parquet file. It's basically a directory of files that are partitioned across the data lake, and one for sales. Right, you'll see the same thing. Tons of small files in here. This one's larger because there's more data, so it's going to split it out into more files. And that's basically what this command is doing. It's writing the summarized data directly to there. And we'll get back to that at the end of the presentation, where that data goes. So now it's sitting in my data lake. And part of the other data that I want to bring in is I want to take this data and write it to SQL. In my case, I'm going to use my SQL managed instance, although I have provided code for you to be able to write it into Azure SQL Database itself. Now, this is sort of my documentation of, I created a login, I created some tables that are going to match. One of them is going to match the sales data that we wrote into a Parquet file. The other one is the customer data they wrote to a Parquet file. And the third table is summary data that I'm going to write directly from this notebook to SQL. Right, and then just some other stuff. Right, so first order of operation is I have to actually get Databricks, just like I got it to connect to my data lake. I have to get it to connect to my SQL database, SQL managed instance. You can also connect it to a SQL data warehouse, which is now renamed to SQL Synapse. It's pretty easy. You just need to sort of have the information available. You can get that from the portal very easily. You get your host name, you get your port, and the database that you want to use. And this code, what it'll do, simply will take these sort of parameters and pass them to a command that allows me to connect and read from my database, right? Actually, when I ran this command, there was no data, so it just gave me an OK, because there's no data in my table. Had there been data, it would actually display the data from the SQL instance, and I'll show you a little bit later how it's done here. So I'm going to create a view for my summary data, and I'm going to take this summary data and I'm going to write it directly to my SQL managed instance using the URL I created above, which is basically the connection string. And then the connection properties is basically the set of properties that include username, password, and a bunch of other stuff in there. This code is available widely in Databricks documentation and Microsoft's documentation. Shouldn't be too hard to find at all. So you can customize it as needed. As you can see, I'm doing a display here of this data frame, which is basically reading directly from the table that is in my Azure SQL Managed instance, right? And I can actually bring that up right here. You can see here are the counts. If I want, I can just do a select star here and actually display my summary data. Oh, well, you can't see that because it's on the wrong screen. Sorry about that. Okay, there you go. What I did earlier was just display counts for the different tables that I had here. But anyways, here's the data basically written from my my Databricks data frame directly to my SQL instance. Another way we can do it, I'll quickly go through this because it's a little outside of the scope of what I planned, but we can use something called delta tables. Actually, my cluster's spun up now, so I can show you what my delta tables will look like. These are my delta tables inside of my Databricks cluster. And I'll explain shortly what this is once it loads up. Oof, it's taking some time there. Right, so here's my delta table. There is no history on here, but it should show the history of what's being done. Oh, there it is, it popped up now. It'll show me the history of what's being done to this table. So if I decide to make any updates, changes, whatnot, it's not actually going to change the underlying data files or files in your data lake that store the data, but what it's going to do is it's actually going to create transaction log files, sort of like how you would create a transaction log file in SQL and write transactions to it. It does something very similar to these Delta Lake tables, and that's why it's called Delta Lake, because it allows for some sort of changes and allows you to go back in history and look at data at a certain time, right? They're not too difficult to create. One thing I will sort of complain about is it's very hard to go back and forth between stuff in a workspace. As you saw, I had to reload my notebook from the beginning. It's just one of those quirks of this development environment. So yeah, I just needed to say that. But anyways, what I've done here is I've created several Delta tables within my Databricks Delta store. And what that is basically is this, right? Let's use a darker color here. So I have my Databricks cluster, right? Databricks, I promise you that was a D. And I have my my data lake, right? ADLS. Okay. And I have this is my customer data, right? It is a text file, just plain TXT file. So anything that I do is not going to affect this actual file, right? Because the data is immutable. What Delta Lake does is it creates these, they call them transaction log files, right? And they're basically just Delta files that says, hey, this table, the customer name was Ayman, right? And that's the original data, and the new data is going to be Ayman, like that, all right? What's going to be written to the Delta file is basically the change, and the actual file stays the same as is. Doesn't change anything. And the advantage of this is in an ETL or data engineering project is a lot of times things change in the data. And we want to be able to, number one, track those changes to understand it. And number two, ETL processes sometimes break and they stop working. So would you like to start the process from the very beginning, reload that, 1 terabyte file or however large it is back into memory, wait for it to load and start all over again? Probably not. So the Delta format, which is an open source format, allows you to actually add some sort of transaction resilience, some sort of asset compliance to these operations that you're doing over data. Again, you'll see this data still sits in my data lake, not in Databricks. Although Databricks does have some storage, they don't recommend that you use that storage. They recommend that you use your data lake, whether it be ADLS or S3 if you're working in AWS or whatever it is. All right. So here I just have a couple cleanup activities. I'm creating a database so that I could store all these Delta tables, and every time that my cluster runs, the Delta tables are already here. I don't have to recreate them, right? DB utils is sort of a way of doing low-level discovery / operations on the Databricks file system, which DBFS, that's what DBFS stands for. Whoops, sorry. I'm just sort of removing directories, creating directories, and setting up things for my Delta Lake. And what I've done here is I've taken my data frames that I created above and all the examples above, and I'm creating a Delta table for each one of them. This is the location that I will be saving the Delta files in. So it's on my Databricks file system, which is, I'm doing air quotes, internal to Databricks, but it's really not. It's still, in this case, it's still going to be on ADLS because it's in Azure. And this is the file path, the Delta test silver, and this is the name of the file path where I'm going to dump the Delta files, basically. And simply create table. This is the name of the table I want to create, my database name, my table name, using Delta. It's a keyword to instruct the cluster that is going to create a table using the Delta format. And this is, again, the location. So this command will actually take my current format of the structure for my data frame known as customer data sales, and it will create that format and structure in this table, right? So when I go in my data here, I'll look for it. Which one was it? Customer data sales, right? I'll click on customer data sales. I'm not going to click on it because it's going to exit this notebook, but you would see the structure is already saved in there using this create table statement. So I don't have to specify the columns. So it's almost like reading the schema directly from the data frame and then creating a table according to that schema. If you're familiar with the copy into command on Synapse, it's very similar to that. And now what I've done is I've created these what I call silver tables, and now I'm going to create a gold table. It's a long discussion, but there is a concept of bronze, silver, and gold Delta Lake. Bronze being sort of the almost the landing or staging data, and then silver being sort of cleansed, and then gold being the data that you're going to load in your final area, whether it be a database or a Parquet file or an analysis services cube or wherever you're going to load it. Gold is sort of the standard. And we do this because there are a lot of folks that like to see the raw data. They like to see bronze data. They like to see silver data. There are folks that like to see data all across the pipeline. Maybe they're data engineers, data scientists, data analysts. So the advantage of this is it allows everybody to use the same set of data as they see, as they please. So what I'm going to do is I'm going to create my customer final table. And this is the path for it using Delta. And I will, as you can see, I do a regular select from it. I use the limit, which is sort of like a select top 20 in the SQL Server world. There's nothing there because I haven't loaded data in there yet. And I'm going to take all of my different Delta Lake tables, and I'm going to insert it into my gold standard table here. And basically, that pretty much sums up all of the data that we were pulling using the other commands. This is just a different way to do it using Delta tables, basically. Right? I can choose to do any type of SQL statement I want across it. I chose to do it by source system because each one of these comes from a different path, right? So one of them is streaming, sales, retail, and marketing. And what I'm trying to show here is that my final goal table has data from all of those different sources. So basically, you know, completing the the whole idea of the ETL process, right? Two last things I'll show before we open it up to general QA and close out here. One is this is the integration with Azure Data Factory. Specifically, this is how I ran this demo end to end. So in my SQL Server, I have a store procedure that runs, truncates the tables, and then I have the run notebook activity. And that run notebook activity, what it does is it pulls data from all of these files and puts two of them into the Parquet format, and the third data set writes directly to SQL. And then afterwards, I have a copy activity that basically copies these Parquet files into SQL Server. I could have done it directly from Databricks. I just wanted to demonstrate how you can do different things in different places within sort of the ecosystem of Azure. It's very easy to set this up. You just pick, where is it? Databricks activity. You drag it here. You let it know your Databricks environment. So you're going to connect to it. You're going to then tell it where the notebook is. Where's the notebook? Here's the notebook. This is the name of the notebook. And that's it. The only challenge in creating this environment, or sorry, creating this connection, is there's an access token that you need. And you can get that easily from, I believe it's under the admin console here. Let's see. Advanced, nope. Oh, here it is. Yes, under user settings, you can generate a new token. I can say this is for ADF demo NoVasQL. All right, I'm going to put 1 day so no one else tries to use it. Click generate, and you will see this token here. And this token will never be shown again. It says, make sure to copy token now. You won't see it again. And they're freaking serious about this because I've never been able to get this token out. I've had to recreate it every time. You copy this token and you put it right in here. And that's pretty much it. You can start running your Databricks notebooks within Azure Data Factory. I said two things, but I'll actually talk about three things. So that's one. The second one is if you create data flows here, what data flows does is it actually takes these activities. I know this is a little bit out of the context of Azure Databricks, but it's still very relevant. You're going to add a source, right? You're going to add a transformation, and then you're going to add a sync, and you can do joins on different sources and a bunch of other stuff, right? Essentially what data flows does is it runs a managed Databricks cluster on the back end to process this data. So data flows actually uses Databricks in a code-free fashion, right? I personally like to code, so I don't mind doing any of this coding for ETL. The last thing I'll show you is a project that I'm sort of working on, going through one of these Spark books. and it's to pull down NOAA data. If you know NOAA, it's the oceanic atmospheric weather data, basically. And the one thing I wanted to show you here is not to go through the whole notebook, but to show you that I can actually load data directly from, web data sources into my Databricks cluster. So this is publicly available data. It's just a text file sitting on their server somewhere, and this one's a text file on their FTP server. What I'm doing is I'm just downloading them locally to my Databricks file system, and then I can play around with them. And this is just sort of the flexibility that comes with Databricks. Trying to think about how I would do this in the SQL Server world, maybe slightly more difficult. Maybe I need an SSIS package to download things first, or to create some sort of an API that I can, push data down to the server or whatnot. But a lot of these commands exist directly inside of Databricks. So it makes it an easy platform to get data from different places and use them. And as I said, they can be structured, they can be unstructured. It doesn't really matter at this point. You have a lot more flexibility than in a traditional relational or dimensional space. So that's all that I have. I will put up my last slide here that has resources available. I have these notebooks posted on my GitHub repo. You can choose to follow me or not, or choose to make fun of me on Twitter. I have my YouTube channel. I believe this video will be posted on YouTube later this day or this week. And the intro notebook that I used was available here. So if you want to go and dig a little deeper, here's the resources for that.
All righty. That was a great job, Iman. Thank you very much for going into Databricks with us like this. The demos were especially helpful.
Thank you.
And we'll have we're recording on this right now. Once the video completes processing, I'll share it out to you, and you can post it on your YouTube channel. And then we've got an Azure Data Events channel that we're going to start to post on the NOVASQL site, as well as the Meetup site, as well as the AIML Meetup site as well. Do you have any questions for Iman? Oh, sorry. Were you talking, Iman? Sorry.
Nope. Just breathing.
I hear you. Well, I think we're all ready to breathe and enjoy a longer weekend. Amen to that. Well, if there are no questions, I'm going to let Iman. Oh, sorry. Oh, great session. Some comments. Good. Let's see if there's a question here.
If you have any questions, you can feel free to reach out to me.
That's right.
Through any one of these methods.
This meeting chat is muted. What? I don't think so. All right, guys. Oh, where can we use Databricks mostly? Where is it most likely to be used?
That's a good question. A lot of times when we look at the sort of, let me see if I can get a blank slide and draw a little bit here. When we look at sort of traditional data warehousing, right, you have tons of these data sources, right? You have files, you have databases, you have a lot of stuff. So Databricks can work in two ways. One is it can be part of your traditional ETL. This is going to be my drawing of Databricks. It can be part of your traditional ETL or ELT, whatever you want to call it, or however you want to load the data. But it can also be used for data science workloads as well. So there's a slew of data science libraries in there if you want to run data science models. There is for example, today there's, Johns Hopkins provides the data for the COVID-19. You can use that model to, do your own predictions if you want on the data. You can do all of that inside of Databricks, and Databricks has worked with them to provide those samples and stuff. Sometimes folks want to use it sort of as a streaming destination, so you can actually stream data into Databricks. It can be the place where you process data and then push it into a more traditional database or data warehouse or analysis cube or whatever. I mean, there's a lot of different places that you use Databricks. Me, coming from a SQL world, I use Databricks primarily for ETL. I see another question here. Databricks, can it be used on-prem or as cloud service? So Azure Databricks or Databricks on AWS is in the cloud. It is a PaaS service. If you wanted to create something like Databricks, you would have to come up with your own Hadoop cluster, your own Spark cluster, and you'd have to manage all of that. The advantage that Databricks has is that it manages that for you, so you can focus on actually performing the work instead of managing the infrastructure behind it. And the second thing is that Databricks founders, they are big contributors to the Spark community, and the way that they develop Databricks is that it performs a lot faster than traditional Spark. So the answer is no, but there's a good reason for that no.
Right. Managing all that infrastructure can be extremely tedious.
Yes.
I think that's the last question. Good session. Very good session.
Thank you so much.
Oh,
what skills needed to develop? Yeah. So actually, I see the other question says, what skills need to develop tools to start to take advantage? So I will tell you this. This is related to your last question about on-premise versus cloud. So if you were on-premise, you'd have to learn everything about, Yarn, Hadoop, Scoop, Pig, Hive, all these different animals in the zoo, right? With Databricks, you can bring your existing SQL skills. As you saw, a lot of the code I did was in SQL. You can, learn Python a little bit of Scala if you want. Either one of them should help you, but SQL is definitely a language that's available. You can use R, and the only thing you need is a web browser, right? So, I mean, I've been working in this web browser the whole time. I don't really need any tools. I don't need Management Studio. I don't need any of those other things. So you can also use Azure Data Studio if you like to start coding in notebooks. I would say that that's a pretty decent path to getting familiar with notebooks, is you can use them in Azure Data Studio and just use them against your normal SQL workloads. And then from there, progress to Databricks. But don't be intimidated.
Yeah. All right. Is that it for the questions? It looks like it. All right. All right, Ivan, you go have a good long weekend. Everybody have a good long weekend. We'll, if you're going to hang around for the Tuesday 10:30 AI ML webinar, that's cool. If not, we'll see you next Friday on the 29th for Azure SQL Synapse, formerly known as Azure SQL Data Warehouse. Thanks, Ivan.
Thanks. Have a great weekend. Bye-bye.
Bye-bye.